Okay, yes. 7b, modeling, which simply means writing an equation. Anytime you see that word model, just think, I need to write an equation, right? For compound interest situations. So we've already worked with some compound interest, and we looked at the compound interest formula, right? The amount of the loan is equal to the principal times 1 plus I raised to the nth power. So we've done a lot of work with that. What we're going to be doing is we're going to be looking at how it was developed, and the reason we want to work on how it was developed is because we can gain more information by using it in small pieces, by looking at the series or the sequence instead of just the formula itself. Okay? So what we're going to be doing is we're going to be looking at how to write a model or an equation that will tell us any one value in the sequence, but then finding those values in order. Now here's the good news. Your calculator will do all the math for you. You just have to know what to tell it. More good news. This formula that they're going to give you for this is on your formula sheet, so you don't have to memorize it. But you do need to know the pieces. So the first thing we're going to talk about a little is we're going to talk about some of the notation. I was a little surprised on the test that some of you just changed the formulas a little bit. So it was kind of odd. So make sure that when you're using the notation, you're looking at the formula and using it as written. Okay? First of all, we have A sub 0. Now remember that A stands for the amount, and A sub 0 is the original or starting amount, often in finance called the principal. So this is of the amount of money that you start with in the beginning, right? And notice it's 0 because nothing has been added to it. This is what you start with. And that's why we've been using this compound interest formula for some of these instead of the series formula. Because if you use the other one, where it has the n minus 1, you have to be starting, if you'll notice the notation for that one, it's a to the 1. So that's not the original or starting amount, that's the first number in the sequence. That's two different things. And so if you mix up these formulas and use the wrong thing, you're going to find out that you're going to get the wrong values. You're going to see that when we get your test back, some of you, not all of you. Okay, then we have the notation a to the n. That simply means the loan value, and I call it a loan value. It could be an investment too, right? You can earn interest or you can be charged interest. It's the same formulas. The loan value after, I can't spell. Blame it on the COVID. After n years. Remember that n stands for the number of years or the number of compounding periods because it can be more than 1 year. Mm-hmm.
And so is that the answer?
Sorry? Well, it's just one of the values you're going to use, and it can be the answer. If you're looking for a to the n, the loan value, yes, so it can be the answer as well as being part of the formula. You'll also see that you can build by using a to the n as well. Okay? And then finally, we have a to the n plus 1, and that simply means the next term. So if add 1, that means you want the next term, right? So a to the 0, a sub 0 is the original value. A to the n might be like, say, a with a 2 at the bottom, a sub 2. That means after 2 years, right? And a to the n plus 1 is just a general notation for wanting the next year. So if you know a sub 2, then a to the n plus 1 would be a sub 3. So you're looking for the next year, the third year. Okay, hold on just a minute. You have a question? Mm-hmm.
Could you have like n plus like 5 if you were trying to find the fifth one?
No, you'd have to do them one at a time in sequence. So it's always, you can only, with what we're going to look at in a sequence, you can only find the next term in a sequence.
Okay.
With the big formula, you can find some more information, but for these, you can only find the next term in the sequence.
Can a to the 0 be just a?
No, because we need it to be to indicate the original amount. So use a to the 0, a sub 0. Remember, these are called subscripts, so that's a sub 0, a sub n, a sub n plus 1, a sub 3, whatever. So subscripts to keep so that you don't confuse them with exponents. All right, so what we're going to do is we're going to use a formula for working with these. Now, I'm going to write out the formula, and then there's going to be some pieces of it that we need to remind you of, and we'll talk about. To find the next term in the sequence, a to the n plus 1, we're simply going to take r times a to the n. And this is read as the next term is r, which is an interest rate. Remember that? Okay, and we'll talk about how to find that piece of it, but a little bit different than just a percentage. Okay, so times the previous amount. Because a to the n is the one we had, right? A to the n plus 1 is the next one. So if I'm looking for the third year, I'll simply multiply my r, whatever my r is, times the second year to find it. Which is good news for you, because your calculator can do that automatically. So all you're going to be doing once you enter the initial equation is hit it'll equals, we'll give you answer, and you're going to put times, and it'll keep on multiplying times the original sequence. We'll look at that and how to do that in the calculator in a moment. Now, what we need to do first, though, is we need to define r and talk about how to find it. Okay? R is 1 plus I. Something that you've seen before. That's that part of the compound interest formula where you're putting in the interest amount, right? And remember that I is simply the percent as a what? Decimal. Okay? Okay. So our multiplier is simply finding a percent as a decimal and then adding 1 to it to find your R. But remember that you can compound more than yearly. So the original sequence formula has n as a number of years, but you can compound more than once a year, right? You can compound monthly, quarterly, etc. Fortnightly, right? Daily, absolutely. Okay? And if that's the case, then I must be divided by the compounding period. For example, if it's monthly, then you would take I and divide it by 12. If it were quarterly, you would take I and divide it by 4. Right? Fortnightly, you would divide by 26. Daily, divide by 365. Right? And even though that some years and some months don't have the same number of days, you still just treat them as if they do. Okay? So if they tell you to compound in a different period, then you're going to have to find the actual rate. And this is given by the formula, if you'll remember it, I divided by K, where K is the compounding periods. Remember that notation? We didn't use it very much, but we introduced it last term. Okay? All right. So let's talk about some steps. You know what the background is? Let's talk about our steps for making this work. First step is to find I. You're going to be given an interest rate as a percent. You simply change that percent into a what? Decimal, right? Okay? And remember, compounding periods when you're finding your I. Because if you're compounding monthly, then you're going to have to take whatever I you get and divide it by 12. Okay? Second step, find R. And that's just simply 1 plus your I. Just take the 1 plus I. Now, these two pieces are not on your formula sheet, but it's things that we've done before, so it's not that hard to find. Then finally, you're just simply going to plug those into that formula. A to the n plus 1, which means the next value, right, is equal to R times A to the n, which is the previous value. And if you're looking at the original one, this A to the n would be A sub 0, your original principal amount, to get your first one. Then after you find the first one, then you'll be looking for the second one, the third one, etc. Okay? Really straightforward if you'll let it be. Okay? Okay. Now sometimes you're also going to be looking for, guys, the amount of interest. And remember that A stands for the value of the entire loan. That's the principal and the interest, right? So sometimes you're just going to be asked about the interest itself. And if that's the case, then you need to pay attention to how the question is asked. For example, if they ask you after in years. So that's in years means after some number of years. Okay? If they ask you that, then you simply take the year they're talking about in years, right? And subtract that value, the principal from that value. And what's left is the amount of interest that you've earned. Remember, capital I is always the amount of interest. Little I is the interest as a decimal. Yes.
So with that, what you're saying is, so are you just using n there as like a
In a year.
placeholder?
Yes, it stands for in a year.
Yeah,
So like if you wanted it for the
after
third
10
year.
years, and then you subtract it.
Yeah, whatever the amount of the loan is at the 10th year minus the principal or original value, that'll tell you how much interest was earned over the course of those 10 years. So this is over the course of, in years, right? Okay? Now, they might ask you another question in a different way, and that's they might want the interest after or in the nth year. So, for example, how much interest did I earn in the third year? Okay? And in that case, then you take the interest you earned in the third year minus the amount you earned in the second year, and that will give you just the interest for that small period. Does that make sense? Okay? All right. Now, so pay attention to how the question is being asked, and that will tell you what you need to be doing. You're also going to have to be able to find out after what year you have a certain amount in the bank or you owe a certain amount. And for that, you're simply going to use your calculator to push the button and do it over and over and over again until the value of A to the n plus 1 is equal to or greater than the amount they want. And we'll look at some examples of that as well. Mm-hmm.
So what's the number on the first page?
A to the 3 minus A to the 2. So the third year minus the second year, for example, right? Okay. So that means the third year minus the second year, and that would tell you how much interest was earned in that particular period. So if I wanted to know how much interest you made between year 8 and 10, I would take the amount of the loan in year 10 minus the amount of the loan in year 8, and that would give me the difference between those two would be how much interest you earned in that single period. Okay? All right, and we'll look at some examples again. All right, here we go. So first of all, oops, that's simple interest, never mind. Okay. Darren borrows $4,000 from a bank. The bank will charge him interest at the annual rate of 9.8%. Construct a recurrence relation or sequence for the value of his loan after n years. All right? So all they want is the formula, just to build the formula. And so what we need is, we need to know how much was the original amount. So we need A sub 0, so the principal. And in this particular case, sorry, it made my principal go away, didn't it? He borrowed $4,000 at 9.8%. So the original amount was $4,000. You have to have that or you can't go anywhere with it, right? And the interest rate was 9.8%, and it's compounded yearly. So let's just go to some notebook paper so that we can find these steps. First of all, we need to find our I. So we're going to take 9.8% and convert it to a decimal, which is just simply going to give us 0.098 as a decimal. Is it compounding anything other than yearly? No. So there's nothing to divide by, but you're actually dividing even though you're dividing, but it's per year, so you're dividing by 1, so it doesn't change. So do you see that division is always there, even if it doesn't look like it? All right, so that's our I. But our formula, our next step, is to find our R. And to find that, we simply take 1 plus the I, which in this case is going to give us 1.098. Now we'll plug that into the formula. The next value, a to the n plus 1, can be found by taking my R, 1.098, times a to the n, which is the previous one. And this is the recurrence relationship for this particular problem. Okay? Now, notice we didn't use the $4,000, right? So what we do is, the complete question should be, the original amount was $4,000, and every next amount can be found by taking 1.098 times a to the n. So this is our completed answer. We need a starting point, even though we're not using it yet, because we're not being asked to find what would the third year be or whatever. All they want us to do is just write down the relation for right now. So if I asked you now to find out what the value of the loan would be in the third year, you can't do the third year without first doing the second year and the first year, right? So what we're doing with this, remember, this formula will only allow us to find 1 year's value at a time. Okay? So we'd have to find lots of different values to make that happen. So let's just find the first year. How much did he have after the first year? So that's a sub 1, right? First year is 1.098 times the initial value, which was what in this case? 4,000. So the first year, can someone do that multiplication? 1.098 times 4,000? So at the end of the first year, he now has $4,392. So how would I do the second year? Yeah, I would take the A2 is just this multiplier times the value of the first year. Now, what I want to do is I want to show you how to do that in your calculator. Okay? So what you would do is, after you've done the first one, then your calculator can do the rest. So you can just simply but what you need to do is, you need to reverse these. But in multiplication, does the order matter? No. So what you can do on your calculator is simply take 4,000 times 1.098. Everybody do that, please. We already know what value you're going to get. So, you get 4,392. Okay? And then your calculator will remember what you've done. So if you just put in times, so you hit equals, and that gave you this, right? Now you can hit times 1.098 again, right? And then after that, you should be able to simply hit enter, 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 and it'll keep on doing it over and over again. It'll do the same formula.